So we're going to start looking at exponential functions today. So far we've seen arithmetic patterns and geometric patterns, right? And we only saw the graph to one of those two patterns so far. Do you guys know which one? Something you're going to want to know by the time we're done. Do we see graphs? Was mx plus b, in other words? That's the graph we've seen for lines. Was that linear graph geometric or arithmetic? Did it add something each time or subtract something each time, or was it like multiplying each time? I think it's arithmetic. Yeah, it like added or subtracted something. That's what the slope does, is it like adds 4 over 1. Or maybe it adds 2 over 3. Or maybe it subtracts 5 over 1. Or no, negative 3 over 7. That's an arithmetic pattern that creates a line. So geometric patterns, like the one that's in this table, or we're going to look at today, we're going to see what kind of curve or line they produce, what kind of graph they produce. Does that make sense to you guys? So we're going to kind of plot some points and see if we can look at what the pattern is. And we're also going to focus on the exponentialness or the geometricness of that pattern itself, because that's really essential for stuff we're going to do with exponents later. So we're going to work with some exponents as well here. Okay, so it looks like we're working with powers of what number? 5. So 5, I don't know if this fits in one of your blanks on your note guide, but 5 is like the base, so I'd write that down. 5 is the base for this pattern, this geometric pattern that we're investigating. So the words geometric and exponential kind of go hand in hand. Okay? You might also write that down on your sheet. Geometric and exponential kind of mean the same thing. There's some little differences, and that has to do with discrete versus continuous. We've heard those words. So the base is called 5 in this case, and this guy is called the exponent. That's why these are exponential. Okay? So let's see if we can fill in the blanks in here and then kind of answer. I think on your note guide it says something about like a pattern going this way and then a pattern going this way. Let's see if we can figure that business out. But let's just fill in some blanks first, okay? Can you guys help me with some of this? So what's supposed to go here? What do you think is supposed to go here? 5 squared is 5 times 5. That's going to be 25. Yes, I agree. I'll try to color code this as we go. Okay? So that's going to be 25. So what should go up here then?
5 to the third power.
5 to the third power, yeah. Cool. So then what should go here? This is why you have calculators out, right? You can count this one up though, right? Like 5 quarters. So this is 25 times 5, that's 5 quarters, that's $1.25. These are all, by the way, numbers you need to memorize. Not necessarily for this class, but for soon. So one of the first things I do day one is have people memorize powers of things. Very important. So what do you guys think should go here then in this next row?
5 to the fourth power.
5 to the fourth. I'm going to go for green in the middle. I'm just going to keep all these off. There we go. So this is going to be,
6.
well, this one's going to be 625, right?
Mm-hmm.
This one I'm going to have to make teeny. Right? Okay. So then this should be 5 to the fifth. Even teenier. Oh, barely made it. And now we definitely need our calculator, because that times 5 is pretty big.
3125.
3125. Nice. My Algebra 2 guys, if they know what they're doing, have those memorized. Okay, so then here we should put 6 of them. 5 multiplied by itself 6 times. And then of course this number is real big. I don't think they have this one memorized. What's this?
5 to the 25.
Yeah, cool. All right, so we went forward without too much trouble, right? We needed our calculator to do some multiplying because, of course, we don't do that longhand. Come on, this is 2016. Okay, so how do we go backwards? Can you guys help me with that? That might be a little more interesting.
5 to the first power.
5 to the first power is here. Yes. So that's boring. That's just 5. So then this would be 5 to the what power? 0. Don't give it away, Clinics. I know you learned this the other day, right? So here's where I think Miss Holloway's directions at the top come into play. So let's think about the pattern before we go backwards. Let's not use our calculator just to get it. Let's see why it is stuff. So that's a good idea, though, Hunter. Okay, so there's a thing about going this way. To go this way in the pattern, what do? You can be looking at the middle, the top, or the bottom. But what is happening to go this way in the table? It is gaining. Good. What do you mean gaining? Can you be more specific?
Adding.
It's
Increasing.
It's not adding each time, right? Because here it like adds 100 then, and then it would add like 500. That's different amounts. So it's increasing, but how is it increasing? It's multiplying. Can't you see it right here? And then times another 5, and then times another 5, and then times another 5. The pattern here is we go from this one to this one, or this one to this one. I think it's on the top on yours, so let me do it on the top, sorry. Do it on the top since you guys are doing it on the top. I'm going to get this exponential introduction thing out of the way. That's what we're doing. So as we go from here to here, it's times 5, right? So I think that's what you want to write about on your note sheet. Is describe in words or in symbols, I don't care what's happening when you go that way. So you guys figured that out pretty easily. It also asks you what's happening when you go that way.
Divided by 5.
Yes. So if you take 625 and divide it by 5, everybody in your calculator, just so you believe it, take that and divide it by 5.
125.
Yes. And just so you believe it, take this and divide it by 5. I hope we get 625. So you're sure, right? So you're solid on this stuff. That's how you develop numerical intuition. That's how people get good at math. That and doing their homework. 25 divided by 5, we can do it in our head, right? That's 5. So we're pretty clear. So now this part over here that we weren't sure about, 5 to the 0 power, we're going to take 5 and divide it by 5. Well, what's 5 divided by 5? It's 1. This is a big time important thing we've just done here. You've just learned that the 0 power of anything, because I can do this with any power, by the way. We could have put 3s, 4s, 7s, 2.7s. In you're doing this multiplying pattern, if you have a 0 power on something, the answer is not 0, it's 1, and that's the reason why. This is big time right here. Besides learning how to graph an exponential function today, this is probably even more important. Okay, 0 power is 1. So then if we need to go back even further, what power is that going to be? It's not going to be 5 to the 0, it's going to be 5 to the negative 1, and then we'll do 5 to the negative 2, and we can keep going. What's 1 divided by 5?
0.2.
It's 0.2 if you use your calculator. 0.2, though, you should know is 1/5. That's 1 divided by 5. Isn't that what you say right there? That's another way to say that. 1 divided by 5. So then if I take 1/5 and divide it by 5, I'm going to get this. And you guys are like, man, this is like hard fraction stuff now. Whoa. Don't make it hard, though. It's 1/25. I'm going to even go outside my table a little. I think you guys have more spaces than me. So then 5 to the negative third, you're like, whoa, I don't know how to cut 25ths into size 5 pieces. But think about it for a second. Look at your table. It's going to be 125 because 5 cubed is 125. So 5 to the negative 3 is the reciprocal of that. If you know 5 cubed, you also know 5 to the negative third power. So negative powers don't mean negative numbers. That's what we've just discovered here. It's very important. We're going to use it to graph this thing, but like I said, that's only important for now. What's really important here is we just learned what negative powers do. They are not negative numbers. They turn into reciprocals or fractions. So if you know 4 squared, what's 4 squared, guys? 16. You also know 4 to the negative 2 power. It's not negative 16. It's 1/16. If you know 7 squared is 49, then 7 to the negative 2 power is 1/49. Okay, this is big stuff. Big stuff. So now, since we've got this stuff, let's use it to plot. Okay? So, the function here that we're investigating is the function y equals, and it's not a line, it's not mx plus b. Where's the x in here? Can you guys see where the x is changing? Have a look for a second.
Okay, I have a question. What if we put it in the middle then? Like, if it's the negative power, so we're putting in negative.
Good question.
Coefficient.
What should we put in the middle? It's a great question. So I think we should probably go, well, no, that's not right, is it? What do we put here? I don't know. I don't think there's really a good thing to put there, right? But here we could put 1 divided by 5. Here we could put,
That one
you guys
should
will have to be
no, that
creative.
one's just nothing.
I don't think it's 0 though, because it's not, 0's not 1, right? Go ahead though, Hunter.
Wait, no, it would be 5 times 1. 5 times 1 equals.
No, 5 times 1 equals 5.
Oh, yeah, okay, no.
It's tricky, right?
Oh,
So
yeah.
this is a hard one to get. That box is tricky. So I think we'll just leave a question mark. Maybe there's a way to fill it in. But very good. So instead of mx plus b though, where's the x here, guys, right? Like I didn't put an x anywhere. You have an idea,
It's the
Kalenda?
power.
It's the power. Yes, that's what's changing, right? It went from 2 to 3 to 4 to 5 to 6. And then we went backwards. You could make it be anything. So the equation for this exponential function is y equals 5, because we were working with 5 to the x. It's not 5x, it's 5 to the x. That's an exponential function. What's that look like? Well, let's graph it. We've got enough points here for sure. So first we know about when we plug 1 in, we get 5. When we plug 2 in, we get 25. When we plug 3 in, we get 125, and then it's just going to get too big to plot, you know what I mean? So I'm going to make my plot go up to like, I don't know, 200. Let's just go to that. That's about as good as we can do. I'm going to say this scale, say this is 100. Some scaling on here. Exponentials are a little harder to graph. And then this one, I'm just going to go 1, 2, and 3. And I'll go backwards. 1, 2, and 3. Now let's plot the points we have. So now I'm just going to plot a few of these points. These are just too big of numbers. They're going to go off into the beyond. So I'm going to get those out of there so we're not distracted. And that should help some. This one's pretty big too. I'm going to get that out of there. I'm going to get these out of there so we're not distracted. Okay. So when we put 3 in, we got 125. When we put 2 in, we've got that. That's what we're plotting. So 0 is the most important part. That's the y-intercept. What's the y-intercept of an exponential? It doesn't show up here unless you know it. Y-intercept of exponentials, though, is generally 1. So it's going to be way down here at 1. So imagine that that dot is at 1. Okay? They always cross at 1 unless you do what's called transform them, which we'll do next semester. When you put 1 in, you get 5. So this guy's just going to be barely higher because my scale's so big, right? It's 50. When you put 2 in, you get, now it jumped a pretty good amount, right? Now it's at 25. So 2 is like right here. When I put 3 in, it jumps a lot more. Now it's at 125. Now it's like right there. And if I were to try to put 4 in, and we have 625, so 4 right here would be like way, way up on the ceiling somewhere. I'm not going to draw on my ceiling today. Okay, so now if we put -1 in, it's just 1/5. Kalena said a second ago, that's 0.2, teeny. So it's going to be hard to draw this guy. It's going to be like really teeny, really close to 0. And when I put -2 in, a 25th is even smaller. You guys want to put that in your calculator? What's the decimal for it? Tell me. .08?
4.
Like that?
No, it's actually, okay, no, I lied, it's 0.04, not 84, just 4.
That looks better.
Yeah.
Okay. So then what's this one? 125th? 1/125th? Gonna be even smaller. I bet it's like What is it?
It says 8u minus 0.
0.008.
We're going to learn about what that means soon. So I'm going to leave that alone today. So those guys are really, really tiny. Just to be color specific, you know, that's like so close. And then this one's even closer. I can't even draw that anymore, right? And this one's even closer. What do you guys think, though? If I keep going down and getting 1 over 625, 1 over even bigger numbers, am I ever going to touch 0 exactly?
No.
The answer is no. You're going to get closer and closer and closer to kissing 0. Exponential functions have a special feature. We draw it as a dotted line. That special feature is called an asymptote. They get really close to touching and kissing that asymptote, but they never get there. So, can you guys see what shape this has? It's not straight, obviously. It's going like this. Never quite touching the asymptote. It gets so incredibly close that you think it will, but it doesn't. This is a shape you should burn into your mind. This is what exponential functions look like. We'll see some different kinds of ones. You guys are going to look at that in your assignment. So, I'll see you next time.